Good afternoon, students. My name is Samuel Chukwuemeka. We shall continue our study of discrete mathematics. In this case, we shall look at a very important branch of mathematics that is called number theory. Number theory is that branch of mathematics that deals with integers. It deals with integers. Initially, the scientists that earlier discovered this number theory, that is G.H. Hardy. He just demonstrated how numbers could be a beautiful branch of mathematics. However, he didn't really show of what uses are these numbers in mathematics. So towards the 1900s, towards the late 1900s, we found out that the number theory is an important mathematical application that could be used in cryptography. Cryptography deals with systems for secure communication, whereby you can encode message and decode message, using public keys and private keys, so that we to establish secure communication. So this number theory, and specifically what we call a GCD, is a very important application in the cryptography, in encryption, and we shall have to look at it. Now, there are some topics under this number theory, and what we shall look at today is what we call Greatest Common Divisor, or GCD. Now, why are we learning GCD? GCD is very important in encryption. Especially there are some algorithms. There are some algorithms that are used in encryption. Like a popular algorithm used in encryption is the RSA algorithm. RSA algorithm, discovered by Rivest, Shame, and Adelman algorithm. So when you study the algorithm, you will see that they used GCD. So that is why we are using this. And this algorithm is necessary for secure communication, establishing secured communication systems. Okay, this is just a little bit of the history so that you can have an idea why we are learning this. And now let's go to the main stuff. Greatest Common Divisor, GCD. In some textbooks in Nigeria, we call it the HCF. Highest common factor. We call it the highest common factor in Nigeria, HCF. So, if you see, I don't know, some textbooks, you might say this, highest common factor. Some people call it a greatest common measure. Greatest common measure. Greatest common measure. GCM. So it all depends, whatever you see, but they mean the same thing. So let's break this down. First of all, it's a divisor, and it should be a common divisor, but it should be the greatest common divisor. So let's say you have a pair of integers, a pair of positive integers. For this topic, we shall just deal with positive integers. Okay, you have a pair of positive integers, right? Okay, you find the divisors of the integers. Then you now find a common divisor of the integers. That is a divisor that is a factor of the first integer and is also a factor of the second integer. That is a common divisor. Then you list all the divisors and you pick the greatest common divisor. That is what we mean. So we can define GCD as is defined as the greatest integer, greatest positive integer. Because we are dealing with positive integer. Greatest positive integer that can divide a set of integers without a remainder. So if we have just if we have two integers, a pair of integers, then the GCD of that pair is the greatest positive integer that can divide those two integers without a remainder. Say, example, say you have two integers, A and B, right? We have two integers, A and B, right? The GCD of A and B, of integer A and B, let's put it integer A and B. We have two integers A and B. The GCD of integers A and B is represented by, how do we represent it? Represented by, we write GCD, we open up a parenthesis, A comma B. That is how we represent it. GCD of A and B is represented by GCD A comma B and is defined as the greatest positive integer that can divide both A and B without a remainder. So this is just a simple definition of GCD of A and B. Now, our interest now will be, how do we find GCD? We have, for this topic, we shall list 3 ways of finding GCD. Okay? 3 ways of finding the GCD of a set of integers. So the first one we have is by listing. Okay, that's the first way. The second way is by a prime factorization. That's the second way. And the third way, we have the Euclid's algorithm. Euclidean algorithm. So we shall discuss these ways. So you have to watch out for other videos. I'm going to talk about the 3 of them. But before I go, this video, I will just talk about listing. Listing is the kind of the easiest one. So let me just talk about it in this video, and then you watch another video for prime factorization and another one for Euclidean algorithm. Now, for listing, assuming you know the listing is pretty much straightforward. Let's say you are told to find the GCD, example 1, find the GCD of 12 and 18. We are told to find GCD of 12 and 18. So first of all, let's list the factors of 12, you know. It can be called the highest common factor. You know, you call it divisor or its factor of that. Okay, so we have 12, the factors of 12. Okay, we have you can also watch my video on factors and multiples. I did a video on factors and multiples, so it would be good if you can also view that video prior to this one. So factors of 12, you have 1, because 1 can divide 12 without remainder. 2 can divide 12 without remainder. 3 can divide 12 without remainder. 4, 5, no. 6, 7, 8, 9, 10, 11, 12. So these are the factors of 12. Then you have the factors of 18. 1, of course, 1 is the factor of everything. 2 can divide 18 without remainder. 3 can do the same. 4, no. 5, no. 6, no. Yeah, 6, yes, I'm sorry. 6, yes. Can divide 18 without remainder. 7, no. 8, no. 9, yes. Then 10, 11, 12, 13, 14, 15, 16, 17, 18. So now, these are the factors of 12, these are the factors of 18. So, you now ask yourself, of these factors, what are the common factors, or what are the common divisors? You can call it factors or divisors. Let's say divisors or factors. It's the same thing. Divisors or factors. So you now say, what are the common divisors? Yeah, let's be using divisors, because if I'm using factors, it will be as if I'm in Nigeria. So let me just forget about highest common factor. I'm not in Nigeria. If I go to Nigeria, I will use this. But I'm here, so let me use divisor. Okay, the common divisors, we have 1, because we see 1 here, 1 here. You know, it can divide both. 2 and 2, you have 2. 3 and 3, you have 3. 4, no. 6 and 6, you have 6. So these are common divisors. So the greatest common divisor now. So the greatest common divisor. So greatest common divisor is 6, because you have that. These are the common divisors, and then the greatest of them, the greatest common divisor, is 6. Okay, let's do one more before we close this video. What if I say find the GCF of something like 30 and 105? Let's see. So we have divisors of 30. Divisors of 30, then divisors of 105, divisors of 105. Okay, then we have the common divisor, and let's find the greatest common divisor. So I've removed factors. Let me deal with only divisors. Okay, now divisors of 30, you have 1, you have 2, you have 3. Now, sorry for interruption, but on my website, you might want to, I put a link there to tell you what numbers can divide what number. Like, how do you know whether a number is divisible by 3? How do you know whether a number is divisible by 4? So please look at my website to know what numbers can divide what numbers. If you look at it, you should tell. This will help you, because when you encounter large numbers, so that you can know which one can divide which. Okay, so 3, 4, no. 5, yes. 6, yes. 7, 8, 9. The next one is 10. 10, 15. We have 15, and we have 30. Okay, for 105 we have 1. We have 3, because 1 plus 5 is 6. 6 is divisible by 3, so it will work. You have a 5. You have a 7. What else do you have? Of course, you have 1, 7, 35, 15. You have 21. You have a 15. You have a 21, right? And then you have a 3, 3, 9, 15, 5. You have 35, and you have 105. Right? These are the numbers that are divisors of 105. Now, when you encounter large numbers, you might want to, first of all, there's a way I found out. After 5, of course, I know 6 won't go, 7 will go. So 7 goes into 105, 1, 7, 35 is 15. Okay, 8 will not go, 9 will not go, 10, 11, 12 won't go. Okay, so that now if 5 goes into this, it gives you 21, and if 3 goes into this, it gives you 35, and then 1 goes into this, it gives you 105. So just like kind of doing it, if 10 goes into 33, 3 into 30 will give you 10, 2 into 30, 15, 1 into 30, 30. That's when you have big numbers. But when you have small numbers, look at my website, look at that link on my website. It should tell you what number can be divisible by what number. Okay, so common divisors, we have 1, we have 3, we have 5, we have 15. Right? And the greatest common divisor will be 15. Okay, now this is listing. This is a listing. Now, you might ask me then, why are we learning prime factorization and Euclidean algorithm? What if I ask you, find the GCF of 250 and 1500? Would you come and list all this? It would take so much time. It would take forever. So, because of that, we now have prime factorization and Euclidean algorithm. Now, Euclidean algorithm is by far the best algorithm for finding GCD. And we will talk about that in our next video. Okay. Thank you so much, students, for listening. If you have any questions, feel free to ask, and you have a wonderful day.